For this video, we're going to be discussing multiplying and dividing exponent rules. So, when we're performing operations like multiplying or dividing exponents, there's several rules that make the work shorter and simpler. So, we're going to go over what some of these rules are and see how they can make our lives easier. So, our first rule is about multiplying exponents. So when I'm multiplying exponents with the same base, as in x is the base here, the exponents get added. So if I take x to some a power times x to some b power, well, that's the same thing as x to the a plus b power. So here's a long explanation for how that works. If I take x cubed times x to the fourth, we know x cubed is x times x times x. And we know x to the fourth is x times x times x times x. All right, well, these parentheses are just telling multiplying, so I can kind of get rid of them. So that this is one giant multiplication problem. I have 1, 2, 3, 4, 5, 6, 7 x's being multiplied together. You should know that that is x to the 7th power. Well, x to the 7th power, that's x to the 3 plus 4 power. So instead of doing all this long work, I could have said, oh, well, x to the 3 times x to the 4, that's just x to the 3 plus 4, that's x to the 7th power. All right, and this works no matter what. And the reason that we use it is, sure, this isn't that big of a deal. I could just write out this big long thing. But what if I'm doing h to the 23 and h to the 17th? You don't really want to write out all of those x's. These rules make our lives a lot easier. So let's do this try problem down here. Okay? Take a second, see if you can figure this one out on your own, and then I'll work you through it. All right, now that you've tried it, let's check your work and see if it works. And maybe I should have mentioned this before, but if I'm doing this multiplying here, I'm actually going to rewrite this using the commutative property so that it looks like this. 2 times, that should be a multiplying. 2 times 3 times h to the 23rd times h to the 17th. Okay, I just reordered my numbers here. All right, 2 to the 3rd, you should know, or 2 times 3, you should know is just 6. All right, and then h to the 23rd times h to the 17th is h to the 23rd, or 23 plus 17, using our rule up here, which just gives me 6h to the 40th power. And that's my answer. All right, see how the rule makes the work a lot simpler. I don't really want to write out 40 x's across my paper. That would take me forever, and I don't want to do it. Okay? It's easier to just use the rule. Similarly, when we're dividing exponents with the same base, I subtract the exponents. Okay? So when you multiply, like x to the a times x to the b, you add the exponents. And when you multiply, you subtract the exponents. All right? So let's take a look at an example of this. Over here, I have x to the 5th divided by x squared. Well, to help you understand this, I wrote it out the long way. X to the 5th is x times x times x times x times x. X squared is just x times x. Well, now if we look, I've got an x here and an x here. You should know from multiply, or from just basic division, it's on the top, it's on the bottom. They cancel each other out. This x cancels out this x. I'm left with 3 x's, which is x cubed, which is x to the 5 minus 2. So instead of writing out all this work, I just could have said, well, x to the 5th over x squared, that's x to the 5 minus 2, that's x cubed. And where this really comes in handy is once again when we have big numbers, like if I said a to the 50th divided by a to the 29th. I don't really want to draw out 50 x's on top and 29 on the bottom. It's much easier for me to say, well, a to the 50th minus a to the 29th. I'm sorry, a to the 50 minus 29. Well, that's a to the 21st power. All right, so what I'd like you to do is go ahead and try this problem here. All right, now that you've tried this problem, let me help you work it out. What I would think would be a good first step is to separate out my coefficients, 6/2 like that, and x to the 8th over x to the 4th like this. Trust me when I say it'll make our lives easier. 6/2, you know, that's just 3. X to the 8th divided by x to the 4th is x to the 8 minus 4 power. And that just gives me 3x to the 4th power, because 8 minus 4 is 4. So there we go. 3x to the 4th power is my answer. Now, what if I gave you something that looked like this? M to the 10th divided by m to the 12th. Well, if you work that out, you get m to the 10 minus 12, which equals m to the negative 2nd power. And that's kind of weird. All right, negative exponents are kind of weird. And we're actually never going to write an answer. It's going to be kind of a rule for our class that we never write an answer with a negative exponent in it. And that brings us to our third rule, which is the negative exponent rule. And what that rule says is that when a number is raised to a negative power, that's the same thing as 1 divided by that number to the positive power. So for example, x to the negative a is equal to 1 divided by x to the a power. So like if I said x to the negative 4, that's the same thing as 1 over x to the 4th power. And let's kind of do an example of that. If I wanted to, well, never mind. I'm not going to use this calculator. It doesn't do that. Never mind on that. I'm not going to show you an example. But just know that anytime I have a number to a negative power, that's the same thing as 1 over that number to the positive power. And this is how you're going to be writing your answers for me. You're never, ever, 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 ever going to write your answers with a negative exponent in it. I will mark them wrong. Instead, you're just going to mark them, or instead, you're just going to convert these negatives into 1 over that as a positive. So here's an example I've got worked out for you. We've got 4x cubed divided by 2x to the 5th. Separated this out, so it's 4 over 2 times x to the 3 minus 5. 4 divided by 2 is 2. 3 minus 5 is negative 2. And I never want to write this like that. So I can think of this as being the same thing as 2 times 1 over x squared. Think of that as 2 over 1. 2 times 1 is 2. 1 times x squared is x squared. This results in 2 over x squared. All right, so why don't you go ahead and try this problem right here, and then we'll work it out. All right, now that you've tried this problem, let's work it out together. Let's first start by separating out these coefficients. 9 over 18. And then I've got x to the 8th over x to the 12th. All right. 9 over 18, that reduces to 1/2. X to the 8 minus 12. That's 1/2 times x to the negative 4. We're going to use our negative exponent rule here to say that's the same thing as 1/2 times 1 over x to the 4th. Combine those two fractions. 1 times 1 is 1. 2 times x to the 4th. And that is our answer. 1 over 2x to the 4th. So anytime you have a negative exponent, that's the same thing as 1 over the positive exponent. All right, so let's put this stuff together. Let's do some examples that have a little bit more work to them. So example 1 here. I've got 2x to the 4th, y to the 7th, times 3x to the 5th, y to the negative 8th. So what I've got here is I've got, not only do I have some coefficients, I also have two different variables. So my first step is to rewrite this problem. And I'm going to pair off my like terms. So I'm going to say, all right, I've got 2 times 3 times x to the 4th times x to the 5th times y to the 7th times y to the negative 8th. All right, 2 times 3, you know, is 6. When we multiply we multiply terms with common bases, we add the exponents. So this is x to the 4 plus 5. This is y to the 7 plus negative 8. All right, this gives me 6. 4 plus 5 is 9, so x to the 9th. 7 plus negative 8 is y to the negative 1. All right, we've got a problem. This is a negative variable, or negative exponent. Don't want to leave it like that. Think of this as 6 times x to the 9th times 1 over y. Think of this as x to the 9th over 1, 6 over 1. So I get 6 x to the 9th all divided by y. That right there is my answer. Let me write that a little bit bigger and clearer for you. The answer ends up being 6 x to the 9th divided by y. So all we did, we separated out our like terms, we added our exponents, we converted our one negative exponent into 1 over the positive. So that's it. Our answer is just 6x to the 9th divided by y. Let's take a look at a second example. We've got 15, a to the 12th, b to the 8th, c to the 3rd, divided by 5, a to the 6th, b to the 10th, c. So, seems kind of confusing, but if we break this all out, it'll make it much easier. So let's separate everything out into like terms first. I'm going to put these all into separate fractions, and it's going to make my life way easier. So I've got 15 over 5 times a to the 12th over a to the 6th times b to the 8th over b to the 10th times c cubed over c. All right, well, 15 over 5, that's 3. A to the 12th divided by a to the 6th, that's a to the 12 minus 6, which is just, I'm going to actually write this 3 a little lower. A to the 12 minus 6 is a to the 6th. 12 minus 6 is 6. B to the 8th over b to the 10th is b to the 8 minus 10, which is b to the negative 2. And I know I want to write b to the negative 2 as 1 over b squared, because I don't want to have negative exponents. C cubed divided by c is c to the 3 minus 1, which is just c squared. All right. Since these are all just, think of this as 3 over 1, a to the 6 over 1, c squared over 1, I end up getting 3 a to the 6th c squared all divided by b squared. That is our answer. So I just separated these all out, I simplified them, and then I combined them back together into one fraction. So I'm going to leave you with tonight's try it problem. I've got 2x cubed times 3x to the 4th divided by x to the 5th. So as a hint to get you started, do your multiplying up top and then divide.